Hello everyone, today we'll determine the Planck constant and work function of a metal. So we know from the Einstein photoelectric equation, half mv square is equal to hv minus hv naught. Okay, and also we know that the kinetic energy is equivalent to the product of electron and the stopping potential. So from this we can equate ev and hv nu, you can say it as frequency, then cross divide each LHS and RHS with electron, so we'll get h by v and hv naught by e. So we can also say that this is called the work function. So we have this. So compare this equation, okay, with y equal to mx plus c. So we can know that this is y. Y is equal to the potential to the stopping potential, and this is the intercept, which is this is the intercept, okay. And we know that this is x, which is the frequency, and this is the x, okay. So it is very clear about the diagram. So we know that the slope is equal to the m. So m is the slope, and slope is equal to the tan theta, and tan theta is what? This by this, okay. Now we compare this to this, okay. So the m is equal to the h by e, which is equal to the tan theta. So I already tell that we need to find h and work function. So we already find h by this. Say h is equal to the tan theta into e, and from here we can say that our tan theta is this. So we can also say the stopping difference of stopping potential and frequency, okay. So this is what we got. And now for a work function, so this is equivalent to this. So c is equal to, after comparing with this equation, so we'll get the intercept, which is this, and here is intercept is O to C. So we can write OC is equal to minus of work function by E, and we'll take the mod, and it is intercept, okay. So intercept into electron. So we have this and this. We're done with the determination of Planck constant and work function. So thank you guys.